All right, so let's get started. If you want to use my class file, you could do so. Okay, download that. And so this is where we stopped last time, where we ran the owner example and the predicted class, and then we ran the confusion matrix. I don't know, did I run this? Confusion matrix, okay, where we do not specify, if we don't specify what the response class is, the label that is, it will be chosen alphabetically, the one that, so N comes before O, so non-owner is the positive class. And that would make a difference in terms of some of the measures that we compute, okay, as performance measures. But you can specify if you want a label that is not in the alphabetical order to be our positive class, then we can specify that here. And here are the classification accuracy measures that we generated last time in all. Okay, but we did not, while accuracy and error rate are readily understandable, but there is a whole lot of other performance measures that we have to understand what they are. Okay, so here is the set. Okay, so we will use non-owner as the positive class. Okay, so meaning presumably we want to target the non-owner for some kind of sales promotion. So this is the riding mower example, and we have owners and non-owners, and we are interested in, say, non-owners. Okay, but the probabilities are for owners, so you have to keep track of that. And once again, if you look at the owner, so we have the probabilities already given. Normally speaking, those are probabilities that we have to generate using some kind of model. So we have short-circuited that part, which we will discuss the rest of the semester. We're going to be discussing how to generate those probabilities. But for now, just for the sake of understanding the confusion matrix and the accuracy measures, then we just assuming that those are probabilities. And also, you'll have probabilities for train set and validation set, and we will be usually focusing on the validation set. So let's just assume that this is actually a validation set. Okay, so this set is validation set. So let's go on to the Excel file, and we already populated this. So here we have the data and then the probability. Okay, and we have set up an initial cutoff probability of 0.5, so which means any probability that's greater than 0.5 will be classified as owner. Okay, so here we have the actual class in columns, the predicted class in rows. Okay, and let's assume we will use the notation C sub 1 and C sub 2, okay, for the two values of the target. Now C sub 1 is the positive class. Okay, so we have C sub 1. Suppose that the important class is C sub 1, and that's non-owner. Okay. Now sensitivity is, out of all the actual positive classes, how many are we accurately predicting as actual classes? So that's what sensitivity is. How successful are we? Okay, so in the data set, there's a group of positive classes. How many of them are we accurately predicting as positive classes? Of course, we want to express that as a proportion. So sensitivity is, so here are the non-owners. Of all the non-owners, okay, how many are we? There are 12 non-owners. Out of that, we have correctly predicted 10 of them as non-owners, as C sub 1. Okay. So that is called sensitivity, and this is a very important measure, sensitivity. Okay. And then we have the mirror image of that. Okay. So that's called specificity. Specificity is about the non-positive class. Okay. How well are we excluding the non-positive class, or we are correctly classifying them as non-positive classes. So C sub 2, actual C sub 2, okay, and correctly predicting C sub 2. So that would be out of 12 C sub 2, 11 of them are correctly classified as C sub 2. Okay. So that's our specificity. Okay, now these two are important. I made a mistake. Okay, so that's D20. That should be that. Okay. Now these two are very important measures, and we construct what is called an ROC chart between these two. Okay, and especially in medical diagnosis, these two measures are extremely important. Okay, so let's look at a few others that we have in R. So we have sensitivity and specificity, so these two.